Good morning. Welcome back to Science in Mr. Matt's Kitchen, the worst cooking show on YouTube. So today we are talking about the Earth, and actually for the rest of this chapter, yes, technically for the rest of the school year, we're going to be talking about the Earth and some of the other planets, but mostly Earth. Things we know about the Earth, unless you are those flat Earth people. Sorry. They're just wrong. We're not going to go into it too much there. They're just wrong and have been wrong for a really long time. Officially, the Earth is what's known as an oblate spheroid. We say it's a sphere. It's technically not a sphere. It's not perfectly round. It's actually a little bit wider in the middle than it is at the top and bottom. I can't draw spheres, so not bad. But it's wider this way at the equator than it is that way pole to pole, and that's due to the fact because it's spinning. It's this part out here gets pulled out some, so it squishes it down a little bit. There is video of Neil deGrasse Tyson saying it's pear-shaped, which has led those flat Earth people to think it looks like an actual pear. No, it doesn't. It is a little bit wider at the bottom than it is at the top, and it's a little bit wider in the middle, but it's not that far out. I've got the numbers here somewhere. So the diameter, which diameter is just the distance across through the middle. So the diameter pole to pole is 12,714 kilometers. We'll come back to that in a minute. And this one, so that's this diameter. The diameter at the equator is 12,756 kilometers. So there's a difference, but there's a difference of 42 kilometers. So this right here, 7,901.1 miles, and this is, so the difference is 26 miles. So that sounds like a lot, but over almost 8,000 miles, 26 miles is nothing. And the equators, the circumference, so the circumferences also obviously are different. Circumference, pole to pole. So if you're going to go around the Earth, going north to south, let me see, where's the pole to pole one? It's this one. What is that? 40,008 kilometers. And this one, so if you go around the equator, is 40,075 kilometers. So again, it's bigger, but it's not a lot bigger. This one's 24,901 miles, 24,868 miles. So it's 40 miles, 35 miles farther around. Now, how long have we known that the Earth is a globe? Now, before you say Christopher Columbus discovered it in 1492, Christopher Columbus did not discover that the Earth was round. People had known that the Earth was round for literally thousands of years before that. We've known we know the Earth is round. We've actually calculated how round the Earth is over 2,500 years ago. So 500-ish BC. One of the first people to conclude that the Earth was round, Aristotle, in around 350 BC. He was looking at the moon during a lunar eclipse, and he noticed that, so you got the moon here, lunar eclipse, the shadow of the Earth gets cast onto the moon, and he noticed that the shadow that the Earth cast was curved. And the only figure that can do that is a spherical figure. No other shape can cast a curved shadow like that. And then some other things Sailors at that time were already using the North Star for navigation, and they noticed that the height of the sky, the height of the North Star in the sky varied. So if you were near the equator, the North Star would be down here pretty low to the equator, whereas if you get close to the equator, it's really high. I mean, farther away from the equator, closer to the poles, it would get higher. They noticed that this angle changed based on where they were, how far north or south they were, and again, they concluded that's because it's out here somewhere, and we're looking at it from, you know, different angles because we're on something round. People also noticed that as they were watching ships sail out into the ocean, that they would start disappearing from the bottom up, which means they were going around a curve. There are literally hundreds of ways you can tell that the Earth is round. You just have to be willfully ignorant to not accept that part. Now, so the Earth has an imaginary line that goes through the middle from North Pole to South Pole, and that line is called the axis. That axis, that's the imaginary line that the Earth spins on. So you know the globe, it's that thing that it's hanging on right there. That's the point that it spins around. The axis goes North Pole to South Pole, and it is tilted about 23.5 degrees off of perpendicular with the sun. Now, as you know, our Earth experiences several different types of motion. There's rotation. It spins on its axis, which gives us day and night. There's also revolutions. It's revolving around the sun, which gives us seasons. And then if you want to get more complicated than that, our whole solar system is moving around our galaxy, and then our whole galaxy is moving through the universe. And there may be other motions that we're not even aware of, because we don't even know what frame of reference to compare them to. Alright, so some key stats for the Earth. So the mass of the Earth, how much of it there is, presuming kilograms. Sorry, you're going to have to figure out. Alright, so 5.98 times 10 to the 24th kilograms is the mass of the Earth. That's how much Earth there is. Multiply that number times by 2.2, it'll tell you how many pounds, so double it and then a little bit more. Now this thing times 10 to the 24th means take this number, we're here, we have to move the decimal that many places that way, so I have to go 24, so there's 23, 22, so I need to stick 22 zeros on here. 1, 2, 3, 4. Alright, so it's that many kilograms. You don't want to drop it on your foot. So, some things you probably know. The period of time it takes to make one rotation. The length of a day. Anyone know how long it is? Exactly. It's 23 hours and 56 minutes plus a few seconds here and there. I know most of you probably said 24 hours. Close enough. And then the length of time it takes to make one revolution, 1 year, well, I don't know what that is. 1 year, how long's a year? Right, 365 days. Well, 6 hours and 9 minutes. Both of these are changing also because the spin is slowing down and our orbit is actually slowing down a little bit too. These change a little bit and they're not constant. They're pretty close to constant, but they're not constant. We've known about both of these for a long time. So like this February, what happened in this February that doesn't happen every February? Yeah, we had a February 29th this year. Any idea why we had a February 29th? Well, we call our year 365 days, but there's really this also. What is going to happen here every 4 years? So if we have an extra 6 hours in a little bit every 4 years, what happens if we have 4 extra 6 hours? That's an extra 24 hours, which is an extra day, which means every 4 years we have to stick in an extra day to make up for it. Now, this 4 minutes short also affects it, so it's not technically, so these don't match up. They add almost every New Year's, they have some, well, not every New Year's, but frequently on New Year's they'll have leap seconds where there's like an untimed second where time doesn't go on. And that's just adjusting these. And then also technically every 400 years you'll have a leap century where they don't do, even though it should be a leap year, it's not a leap year. It's just to keep the math right. They've known about this for a long time. The Earth also has a magnetic field. That's why compasses work. It's not perfectly lined up. Our magnetic North Pole is not at the actual North Pole. It's a little bit off. So you have to do some calculations to adjust for that. And our orbit is not perfectly circular. It's actually an ellipse. Actually, all the planets have elliptical orbits, which means they're ovals, not circles. So there are times in the year, so our orbit isn't circular like this, it's actually elliptical like this. So there are times when we're farther away from the sun, times when we're closer to the sun. Oddly, the times when we're closer to the sun are our winter, our winters, actually when we're farthest from the sun, or one of the times we're farthest from the sun, we're closest fall and spring. Our seasons aren't caused by distance, because the few thousand miles difference, few million miles difference isn't going to, our seasons actually caused by the tilt of the Earth. Because if you think about it, sunlight coming from here, the part that's tilted towards the sun is getting much more direct sunlight than the bottom. This is kind of glancing off. Here it's hitting directly, so it's summer up here and winter down here. And then when you're around on the other side, it's coming this way. So now it would be summer down here and winter up there. Let me see. Yeah, that's enough for now. Sorry, it's a little bit longer than I want it to be. But there you go.